Why do SSD sectors have limited write endurance? I often see people mention that SSD sectors have a limited number of writes before they go bad, especially when compared to classic, rotating disk, hard drives where most of those fail due to mechanical failure, not sectors going bad. I am curious as to why that is. I am looking for a technical yet consumer-oriented explanation, i.e. the exact component that fails and why frequent writes affect the quality of that component, but explained in such a way that it does not require an extreme amount of knowledge about SSDs.
Copied from Why Flash Wears Out and How to Make It Last Longer. NAND flash stores the information by controlling the amount of electrons in a region called the floating gate. These electrons change the conductive properties of the memory cell, the gate voltage needed to turn the cell on and off, which in turn is used to store one or more bits of data in the cell. This is why the ability of the floating gate to hold a charge is critical to the cell's ability to reliably store data. Write and erase processes cause wear. When written to and erased during the normal course of use, the oxide layer separating the floating gate from the substrate degrades, reducing its ability to hold a charge for an extended period of time. Each solid-state storage device can sustain a finite amount of degradation before it becomes unreliable, meaning it may still function but not consistently. The number of writes and erasures, P cycles, a NAND device can sustain while still maintaining a consistent, predictable output, defines its endurance.
Imagine a piece of regular paper and pencil. Now feel free to write and erase as many times as you please in one spot on the paper. How long does it take before you make it through the paper? SSDs and USB flash drives have this basic concept but at the electron level.
The problem is that the NAND flash substrate used suffers degradation on each erase. The erase process involves hitting the flash cell with a relatively large charge of electrical energy. This causes the semiconductor layer on the chip itself to degrade slightly. This damage on the long run increases bit error rates that can be corrected with software, but eventually the error correction code routines in the flash controller can't keep up with these errors and the flash cell becomes unreliable.
My answer is taken from people with more knowledge than me. SSDs use what is called flash memory. A physical process occurs when data is written to a cell. Electrons move in and out. When this happens, it erodes the physical structure. This process is pretty much like water erosion. Eventually it's too much and the wall gives way. When this happens, the cell is rendered useless. Another way is that these electrons can get stuck, making it harder for the cell to be read correctly. The analogy for this is a lot of people talking at the same time, and it's hard to hear anyone. You may pick out one voice, but it may be the wrong one. SSDs try to spread the load evenly between its and use cells, so that they wear down evenly. Eventually a cell will die and be marked as unavailable. SSDs have an area of over-provisioned cells, i.e. spare cells, think substitutes in sport. When a cell dies, one of these are used instead. Eventually all these extra cells are used as well and the SSD will slowly become unreadable. Hopefully that was a consumer-friendly answer. Edit, source here.
Beethoven, Beethoven,